Good evening, Titans. This is Mr. Simpson, and tonight we're going to continue with section 11.4 and talk about adding and subtracting rational expressions. We're first going to look at how we add rational expressions that have the same denominator or have common denominators. So just like we would do if we were adding fractions that have a common denominator, like 2/7 plus 3/7, since they have a common denominator, we keep the denominator the same and we just add the numerator. So as you can see, we'll do the exact same thing. If they have a common denominator, we keep the denominator the same and we add the numerators. If we're subtracting, again, we keep the denominator the same and we subtract the numerators. So if we look at an example here, this first one, we already have a common denominator. If you notice, each denominator is just the variable x. So then my denominator is going to be x, because again, we just carry that through. And now we add the numerators. Well, it's 5 plus x plus 7. We're going to combine like terms, so 5 plus 7 will be 12 plus x. And that's as far as we can go. We'd look to simplify if we could, but in this case, this is as far as we can go. Because remember, we can never divide out part of a sum with anything else. In this next example, again, we have identical denominators. So my denominators are going to stay the same, to be x plus y. And now I add the numerators. Well, x and y aren't like terms, but I can write it as x plus y. Now I look to simplify. Well, in this case, I have x plus y in the numerator, x plus y in the denominator, and if I'm dividing two identical sums, they can divide out to equal 1. Here we're asked to subtract. So the tricky thing about subtraction is that, again, we're going to keep the common denominator of t minus 6. But now, this minus sign must be distributed. Just like we've done, we're going to rewrite this as 5t plus 3 plus, and then negative t plus 4. We must distribute the negative to both of those terms. And now we combine like terms. So we have 5t plus negative t would be 4t, and then we'd have 3 plus 4 is 7. And since the numerator is not factorable, this would be my final answer. Here's another subtraction problem. Again, our denominators are already identical, so I keep my denominator the same. And I just subtract the numerators. So it's 3 minus 5 is a negative 2, and that's all I can do. And I believe this is the last example where we have a common denominator. Again, notice that the two denominators are identical, so my answer is going to have that denominator. But now, again, we're subtracting, so I have to make sure I'm going to change this to a plus and then distribute the negative through. So that becomes negative 5 plus 4x. Okay? Now I combine my like terms. So I have 5x plus 4x is 9x. And then I have negative 4 plus negative 5 is negative 9. Now, it doesn't look like anything can simplify, but again, both of these can be factored. So we have to look to factor and then see if we can divide anything out. So the numerator is 2 terms. So I'm going to check, and it has a GCF of 9. So I factor the 9 out. The denominator has 3 terms. So I factor it into a quadratic trinomial factoring. So it's x and x. And factors of a negative 7 that add up to 6 would be a positive 7 and a negative 1. And if we notice here, we have identical binomials in the numerator and the denominator. So I can divide those out. So my final answer would be 9 over x plus 7. And there's your final answer. We're now going to move to adding fractions that have unlike denominators or different denominators. And so you may want to pause this and write some of this down. Obviously, number one, we have to get a common denominator. Then we have to rewrite each rational expression with the common denominator. We have to then adjust the numerators. Then we're ready to add or subtract the numerators. And then make sure we reduce the answer if we need to. So again, I'd pause this slide right here, write these steps down, and now we'll go on to the example. First problem here. This denominator is 3x. This denominator is 4x squared. So we have to find the common denominator. Now as you see, I have it listed right here, 12x squared. But let's see how we get that. In the notes it says we put each in factored form. So if you recall, this is 3x, and then 4x squared is 2 times x times x. And what we do is we take each different factor, the greatest number of times it occurs. So I take the 2's, greatest number of times it occurs twice. I take the 3, occurs once, and the greatest number the x occurs in any one of the factorizations is twice. And if I multiply this all together, I get 12x squared. So that's my common denominator. So now I have to rewrite each of these fractions so they have a common denominator of 12x squared. So now I have to rename the numerators. So I have to decide what's missing from 3x to make it 12x squared. Well, if I multiply that by 4x, that gives me 12x squared, so that's what I have to multiply the numerator by. So 4x times 5 is 20x. Now I have to do the same thing to the other denominator. Well, what times 4x squared gives me 12x squared is just 3. So then I have to multiply the top by 3, and that gives me 18. Well, now I'm ready to add my like terms. So I have 20x plus 18 all over 12x squared. Now, in the numerator, there is a common factor, and that common factor is 2. So again, I'm going to take this, I'm going to move it up here so I have some room. I'm going to factor the 2 out. That gives me 10x plus 9 all over 12x squared. And now the 2 on the outside can divide with the 12. So now my final answer will be 10x plus 9 all over 6x squared. And there's your final answer. And that's how we add fractions that have unlike denominators. And again, if you go back and look at your notes, we followed those steps. We found the common denominator, and then we renamed each fraction and made the adjustment to the numerators in doing that. Then we added the numerators, and then we looked to simplify if we could, and we ended up with this for our final answer. So we'll look at maybe a few more examples tomorrow in class, but again, we'll focus a lot on adding fractions with like denominators and then making sure that we can simplify them, but then also being able to add fractions that have monomial denominators that are unlike, making common denominators out of them, and then adding their numerators.
Made with Doodlecast Pro.